Tests for ferric ion. Ion is a chemical element with the symbol Fe. It is found in salt like ferric chloride as ferric 3 positive ion. In group 3, ferric ion is precipitated as its hydroxide by adding ammonium hydroxide to its solution. Our aim here is to test for the presence of the ferric ion in a given salt. First, we look at the preliminary test for the ferric ion. Borax bead test. Materials required: original salt, borax, platinum wire loop and Bunsen burner. Procedure: take a small quantity of borax powder in the loop of platinum wire by dipping it in borax powder. Heat it in the flame of the Bunsen burner. Borax swells and forms a transparent, colorless, glassy bead. Dip the hot bead in the watch glass containing salt. Heat it again either in the oxidizing flame or in the reducing flame of the Bunsen burner. In the oxidizing flame, the bead becomes yellowish brown when hot and pale yellow when cold. In the reducing flame, the color of the bead becomes green when both hot and cold. Next, we look at the analysis of the ferric ion. Materials required: salt solution in a test tube, concentrated nitric acid, ammonium chloride, ammonium hydroxide, dilute hydrochloric acid, centrifuge, centrifuge tube, droppers, spatula, test tube holder and Bunsen burner. Procedure: take a small quantity of salt solution in a test tube. To this, add a small quantity of concentrated nitric acid using a dropper. Boil the solution for some time over the Bunsen burner. Using the spatula, add a small quantity of ammonium chloride to the solution. Boil the solution again and cool it by placing the test tube in a beaker containing water. Now, add excess of ammonium hydroxide solution to the test tube and shake. Ferric ions present in the salt solution react with ammonium hydroxide to form a brown precipitate of ferric hydroxide. Transfer the precipitate into a centrifuge tube to separate it by centrifugation. Now, add dilute hydrochloric acid to the precipitate and shake. The precipitate is dissolved in hydrochloric acid due to the formation of soluble ferric chloride. Finally, we look at the confirmatory tests of ferric ion. Potassium ferrocyanide test. Materials required: solution obtained in the group analysis, potassium ferrocyanide solution, and dropper. Procedure: take a portion of the solution obtained in the group analysis in a test tube. To this, add a few drops of potassium ferrocyanide solution using the dropper. Ferric chloride present in the solution reacts with potassium ferrocyanide to form Prussian blue colored ferric ferrocyanide. Potassium sulfocyanide test. Materials required: solution obtained in the group analysis, potassium sulfocyanide solution and dropper. Procedure: take a portion of the solution obtained in the group analysis in a test tube. To this, add a few drops of potassium sulfocyanide solution using the dropper. Ferric chloride present in the solution reacts with potassium sulfocyanide to form blood red colored ferric sulfocyanide. Precautions: handle hydrochloric acid and nitric acid with proper care because they are highly corrosive. Heating should be done very carefully.